Hello and welcome to the College of Science training module in the AI Literacy Essentials program here at San Jose State University. My name is Dr. Jean-Marc Grazioli and I'm an associate professor of computational chemistry, and I'm also serving as your AI fellow representing the College of Science. Although artificial intelligence has been around for quite a few decades, the introduction of highly accessible AI, such as the large language models that enable you to talk to an AI model so easily, like, for example, ChatGPT, this is what's making such a major impact. In fact, I feel that this broad impact on our society in general is on the same scale as the invention of the internet or perhaps the Industrial Revolution before that. This high degree of accessibility means that students and educators alike no longer have the luxury of choice of whether or not they want to take AI into consideration with their teaching and learning. At this point, it simply cannot be ignored. These exciting new tools are incredibly powerful, and it's tempting to just throw AI at every problem that comes our way. But it's important to remember that using AI tools is a double-edged sword. In particular to education, what I mean by this is that if you allow yourself to allow too many processes in your field to become a black box where you just sort of throw a prompt at an AI, the AI tells you what to do and you just do it, right? Whether this is maybe a creative writing exercise or writing computer code, you've forfeited the opportunity to build some foundational knowledge in your field. And essentially you're cheating yourself out of what could have been a valuable educational experience. There's even a term for this. It is called cognitive offloading. So an example of cognitive offloading is, think of phone numbers, right? How many people do you have their phone number memorized? Is it maybe some close friends or family, or maybe no one at all, right? It used to be that people had important phone numbers memorized. But once people had phones with contact lists that would remember that for them, they offloaded this. They said, I don't need to think about this anymore. My phone knows everyone's phone number. I can just search for it. A famous example of this, allegedly Albert Einstein did not know the phone number for his office because he could always look it up. So if somebody needed his number, he'd look it up and tell it to them. So why memorize it? Because it's right there in a book. This concept also applies to the use of artificial intelligence. So let's say, for example, you've developed the habit where if you're writing a research paper, you basically type what you want to say to get the point across into ChatGPT, and you ask ChatGPT, okay, please make this sound more professional as appropriate for a research paper. And ChatGPT does a good job of doing that. You copy it, and you paste it, and then you move on to the next section. If you use the AI tool in this way, your writing's never going to improve because you haven't really looked at the output it gave you. So what you should do instead of doing cognitive offloading where you have the ChatGPT worry about making your phrasing sound professional and appropriate for your field, take a look at every output it gives you and think about it critically. What's different between the way you wrote it and the way that ChatGPT wrote it? For example, maybe it's constantly switching your speech from the first person to the third person. So maybe your input was, I allowed the sample to incubate at room temperature for 1 hour. And then ChatGPT changed it to the samples incubated at room temperature for 1 hour, right? This is a change from the first person to the third person. Well, you should pick up on this change that it keeps doing this and start figuring out how to do that on your own so that, first of all, your inputs to ChatGPT will improve, but also you're developing the ability to communicate more effectively and more appropriately for your field. And this, of course, will carry over into conversations with colleagues, if you're giving a poster presentation, if you're giving a talk. In these scenarios, ChatGPT can't bail you out. So make sure that you're always thinking critically about every output that you get from a generative AI. Now, so far, I've limited the discussion to using AI tools that are commonly available that, let's be honest, just about anyone can use. But you're not here at San Jose State to learn to do things that just about anyone can do, right? You're trying to elevate yourself. You're trying to learn new skills, gain new knowledge that's going to help build the future that you desire. So how can you set yourself apart as a scientist in an age when AI is influencing how we all do our jobs? Well, I encourage you to learn to be the sort of scientist who can build or at least train an AI model. And of course, this is something you would probably expect to learn as a computer science major, but really I recommend this to every major within the College of Science. Whether you're a geologist, a biologist, a chemist, physicist, whatever you're studying, there are opportunities to go beyond being a user of existing AI tools and instead become a builder of AI tools. And I mean this extremely broadly speaking. For example, you may work as a computer scientist or a statistician building the fundamental methods. For example, the transformer is an AI paradigm that has changed the way large language models work, and that's a big reason why ChatGPT has become as successful as it is. But perhaps that's a more obvious way to get involved in building AI tools. Let's say that your interest is in science education. Well, perhaps you want to get into fine-tuning large language models. So to give an example of what I mean by this, let's say that you want to build a large language model that will help students with homework and explain how to do the steps without giving away the answer. If that's what you're interested in, you don't need to develop brand new AI paradigms for this. Large language models are already great for this sort of thing. What you need to do is fine-tune a large language model. And I feel that this level of AI tool building is accessible to motivated students from any of our majors in the College of Science. Now, will this require you to learn how to write code? Well, maybe not necessarily, but it's better if you do. Now, I'm not saying everyone needs to become an expert programmer who knows multiple languages, etc., but I'm saying knowing a little bit of Python goes a long way if you want to get into AI tool building. So regardless of what your major is, if you want to become the sort of scientist who is able to incorporate AI effectively into their workflow, I strongly encourage you to try and squeeze in at least an introductory programming course. Additionally, there are so many great resources online to learn how to program, especially in Python. And finally, I encourage you to go beyond the coursework and get involved in student groups that use AI, get involved in faculty research groups that use AI. In fact, even if you don't want to make AI a focal point of your education, I encourage every student to get involved in faculty-led research. So as you move forward with your education and your careers, remember that AI is not just a finished product or a tool that you can use. It's a field, and you can contribute to shaping it. So I wish you all the best of luck, and I look forward to seeing what you create.